Welcome to MySQL Lesson 5. This video will demonstrate some of the topics covered in chapters 4 and 5 in your text, specifically views, stored functions, and procedures, plus an example of query optimization. We will start by creating the view in Chapter 4, Section 4.1. The view is named grade_stats, and it will join the score and grade_event tables from your sample database, as shown here. Now keep in mind that a view is a virtual table, not an actual table, and it will be defined for your database. I click the lightning bolt to create it. After that, if you want to verify that a view actually exists, you can right-click Views within your database definition on the left. Select Refresh All from the drop-down, and you'll see under the views below grade_stats. It doesn't actually contain any records, but you can run a query against it later. So let's do just that. In this query, we're going to select the date category, count, and average, which were created by the view. When we run it, we see the count and average for category Q for the date 2012-9/16. Keep in mind that not all of the columns from the grade event table were included in the grade stats view. So if you accidentally put in the name of one of the columns from the grade event table, such as event_ID, it cannot be part of the query and it would give you an error code. Let's look at an example. Again, the event_ID was not part of the view. I'll go back and add event ID to the query and run it. And there's the error that I expected. For the grade_stats view, event ID is an unknown column. However, we can show span, we can show total, because they are part of that view called grade_stats. And here you see with this query, we're able to show that information also. And finally, just to illustrate that you are able to use the view to select all of the records and all of the columns, here is an example. We select star from grade_stats, and there's the information that you see. Now remember, we were trying to display the event_ID earlier, and there is a way that you can actually add it to the view. There's a nice feature that's called Alter View that the Workbench provides. You'll right-click the view, select it, and it generates a parsed version of the view, just like this. Since the parsed version has different syntax from what we usually see in an SQL file, I'll use a Control-C to copy a line. Down below, I'll use a Control-V to paste it. And then I'm going to actually modify portions of it to fit what we need. We needed the event ID from grade event, and then I'm going to give it a name just like event_ID again. Now I can go down and apply this change, and it will show you the actual generated information for the create. And then I can execute it, and it finishes successfully. So now my view is a little bit different. If I do a select star from grade_stats again, it's actually going to include the event_ID now as part of the view. Let's move on to the next section of this chapter, and we're going to look at how we can create stored procedures and functions. The first one we're looking at is a procedure. It is called greetings, and it is from section 4.2.1. Notice that we're using the delimiter command to allow you to include the default delimiter, which is a semicolon, within that procedure. Otherwise, it would give you an error. I'll run the create statement. And then I can also look to verify that it was actually created by doing a right-click on the stored procedures, refresh all, just like we did with the view, and under stored procedures shows greetings. In order to run that new procedure, I'm going to open a new query, and then I'm going to just type in call space greetings. And notice that even though greetings doesn't have any parameters, I must include an open and close parentheses to satisfy the syntax of the call. I run it, and if you look below, you'll see here's the message. Greetings, root. And root happens to be my logon. Now I'm going to switch from a procedure to a function. If you look in Chapter 4 of your textbook, there's an example in Section 4.2.2 of a function that is named count_born_in_year. A stored procedure is similar to stored functions, but a procedure doesn't return a value and a function must return a value. Also, you must call a procedure and instead you will select a function. So let's look at an example. This particular function will return the number of presidents that were born in a specific year. When you call the function, you will give it the year you're expecting to count, and it will return the number that is counted. I will open a new query tab, and then I will select that function that we just created. All you have to type is select count_born_in_year, open parentheses, and then you give it the year that you're going to count. 1913 in this case. I go up and click the lightning bolt to run it, and there you see the number of presidents that were born in 1913 is 2. The final demonstration in this video will take a look at query optimization. Section 5.2 of your text covers query optimization and some information about using the explain command. For this example, I used the world database which was given to you when you installed MySQL. Query optimization can be very important when you have large databases, and I chose the world database because there are over 4,000 records, and it gives you the opportunity to see how you can save time on a query by adding an index. This query will use an inner join to select from the city and country tables based on the country code, and it will choose only the population, which is over 120,000, and also limits the number of records to be chosen. I did that so I could come up with a good sampling. When I ran that explain command against this query, country code was a possible key, but the explain doesn't always find a conclusive choice for creating an index. By using my knowledge of this table and the results, I see that the country code might be a good choice. I'm going to test my hypothesis by removing the explain command so that I can actually run the query, and let's just see how long it takes to find these records. You'll see the join displayed 2,920 rows, and it took 0.046 seconds to run. That's a number to keep in mind so that when I add an index, I can see if it's going to improve. So I hope to improve the runtime by altering the city table, and I'm going to add the index. This is the command, alter space city space add space index space code space country code in parentheses. After I finished typing this particular line, I noticed that there was an X at the beginning of the line. Usually there should be a blue dot to indicate that the line has been pre-scanned and it's in the correct syntax. So apparently I have a syntax error. I can hover my cursor over the line and it explains the error. I looked up the command and I forgot to put in the word table. Very important. The other thing I didn't like on this particular line is that word code. You see how it is in blue, which means it's used already. So I changed it to C_code, and now I can click the lightning bolt to run the command. And as you see below, it affected all 4,079 records. So now everything is indexed by country code in the city table. Well, let's see if adding that index improved our time. I went back to our original query, ran it, and looked below. 0.015 seconds? It actually saved about 67% of the query time from the original query. That would be a significant time savings if I had, say, 100 times as many records. Just like the view, procedure, and function that we added earlier, we can use the refresh all command to go and look at the city and see that the C_code is now an index in the definition. That concludes the demonstration of views, stored programs such as procedures and functions, and in particular, optimization.